class. So today we are going to start with a definition, the definition of effective annual yield. It's also called the effective rate. Let's look at this problem. This is a problem on section 3.4, 8.4. An account has a rate of 3.9%. Find the effective annual yield if the interest is compounded monthly. This problem requires a formula. Firstly, we need to know what is the effective annual yield, what is the notation for that, and what's the formula to calculate. What's the formula that we can use to calculate the value for the effective annual yield? You click the given formulas, and you will see 1, 2, 3, 4 formulas. The last one, the one on the right, that's the formula for the effective annual yield. Effective annual yield is also called the effective rate, as opposed to nominal rate. As you can see in this formula, Y here is the effective rate. R here is the annual interest rate. It is the rate, but that rate is the nominal rate. That is the nominal rate of the account. Y is the actual rate. When n is equal to 1, when the interest is compounded annually, the nominal rate and the effective rate is the same. You can try. If you plug in n equals 1, 1 plus r minus 1 is r. The effective rate and the nominal rate is the same. But if n is bigger than 1, let's say the interest is compounded semi-annually, n equals 2, quarterly, n equals 4, monthly, n equals 12, daily, n equals 365. If n is bigger than 1, if the interest is compounded more than once a year, then the effective rate y should be higher than the nominal rate, because nominal rate does not consider compounding effect. But this account, if n is bigger than 1, for that year, the interest is compounded more than one time. So take the compounding effect into consideration. We have the actual or effective rate for that year. So for 1 year. So this is very important, okay? And let's see how do we process this problem. In reality, you might heard about APR, APY, right? So when we say effective annual yield, when we talk about yield, that mainly refers to an investment situation. Yield is investment. So if you heard about people say annual APY stands for annual percentage yield. It's the same thing here. Is the same with what we have on the textbook. Is the same with the effective annual yield or effective rate. Firstly, you need to know what does the formula look like. The formula for effective rate Y is the compounding factor. I hope you still remember what is a compounding factor. Is a 1 plus rate. Is raised to the power of n and then minus 1. So that's the formula for the effective rate. Hi, John. Oh, that Rachel, I cannot see any. You cannot see anything. It happened to me before logging out and back in. Okay, all right. So Rachel is. Oh, we have more participants. We have Rachel, right? Okay. Okay. So based on the problem, the annual interest rate, the nominal rate R, is 3.9%, as decimal 0.039, right? And the interest is compounded monthly 12 times a year, So little n is 12. With the values for r and n, we can just plug in them into the equation formula. We can get a value for y. So I would do this, I would find the value for the compounding factor first. Compounding factor is 1 plus the monthly interest rate, is 1 plus annual interest rate divided by 12, right? And let's see what is that value. I'm going to use the TI-84 calculator. Okay. 1 plus parentheses 0.039, 3.9%. That's the nominal rate. It's the annual interest rate that is given. Divided by 12, we have the monthly interest rate. So 1 plus the monthly interest rate is the compounding factor. That's the compounding factor. Compounding factor is raised to the power of 12 because for 1 year, the interest is compounded 12 times. So raised to 12. And then minus 1. And that's the decimal equivalent of the effective rate or effective annual yield. So this is the number. We just need to convert that number to its equivalent percentage. To convert to percentage, we multiply by 100 and then attach the percent sign, right? The percent sign is already attached right here. The percent sign is already in place. So we just need to round this number and put it in the cell. How do we round the number? It says round to the nearest hundredth. So keep 2 decimal places. 0 here is less than 5, so we round it down. Round it down, keep 2 decimal places, 3.97. That's the effective annual yield or effective rate as opposed to the nominal rate. Knowing if the number of times the interest compounded more than 1 time is bigger than 1, then the effective annual yield is always bigger than the nominal rate. The effective rate is bigger than the nominal rate, but not a lot bigger. It's just a little bit bigger. So this number is a very reasonable result. Is correct also. Nominal rate 3.9% without considering the compounding effect. 3.97%, that's the actual effective rate. When we take compounding effect of the account into consideration, it's actually higher than that. I'm going to give you a couple of minutes, and I want you to try this problem and provide your answer. Okay? Right now it's 11. I'll check on you at 13. An account has a rate of 3.5%. Find the effective annual yield if the interest is compounded 1,000 times per year. What does that mean? That means your n, your little n, is 1,000. Be careful. In previous problem, is 12 times a year, so little n is 12. Here, it says the account is an account that interest is compounded 1,000 times a year, so your little n is 1,000. All right. It's actually freezing. It's freezing. I'm going to copy paste this and give it a little time to load. Oh, actually, it's fine now. It's fine now. Okay. I put it here. Then you can see both. You also can see the formula that we used earlier. All right. You have 1 more minute. giving me the result that we're supposed to enter in the cell. The percent sign is behind the cell. It's already given in the system. Rounded to the nearest hundredth. Oh, someone already have the result. Let's see. John, that is too big, John. Let's say that the effective rate is supposed to be bigger than the nominal rate, but just a little bit bigger. That is ridiculously bigger. The nominal rate is 3.5%, 3.5%, and even is compounded 1,000 times a year. Is really that much? Let me see. 3.5%. So, parentheses. Let's do the compounding factor first. 1 plus the annual interest rate, 3.5%, which is 0.035, 3.5%, divided by 1,000, right? Close the parentheses, and this is the compounding factor, 1 plus the rate. Raise this compounding factor to the power of 1,000, and then minus 1, right? And that's the decimal equivalent of the effective annual yield. We multiply that by 100 and attach the percent sign. It's supposed to be 3.56. 3.56. 3.56. Like what I mentioned earlier, the effective annual yield is supposed to be bigger than the nominal rate, but not a lot bigger. It's a little bit bigger. Like this is very reasonable. Nominal rate 3.5%, effective rate 3.56% is correct, right? Yeah. So double check your result. At that's where okay, I don't know which part. Be very careful. I think you can do it by steps. Like what I did is I calculate the compounding factor first, correctly use parentheses. The parentheses is a grouping symbol. How do you use the parentheses? Really important, because if you misuse it, it will change the structure of the expression. Then basically you miscommunicated with your calculator. So you have to give the correct expression to the calculator. Then the calculator can help you to do the calculation. And I found the compounding factor first, and then raise it to the 1,000 times, 1,000 exponent, and then minus 1, and that's the decimal equivalent for the effective rate, and then multiply by 100. That's the number we need to round and enter in the cell. So do it by steps. I am recording the class, am I right? Yeah, I am recording the class. So later you probably want to go back to watch that part. All right, so that's the leftover we didn't finish from last time. I'm gonna now start the section 8.5. Section 8.5. 8.5. In section 8.5, we're going to talk about annuity, all right? In this section, there are also questions related to stocks, bonds, maybe some IRA and Roth IRA. For those questions, I would recommend you you can Google, you can do some research and answer on your own, if we don't have time to cover that, all right? Mainly, we're gonna focus on annuity, okay? And what is an annuity? Annuity is a way to invest. So annuity is a type of investment plan. Annuity is a certain type of investment plan. Let me briefly explain what is annuity. Annuity. Okay. It is a type of investment plan or savings plan. So we are going to talk about annuity as a savings plan. If you contribute equal amount of money at an equal time period, then that type of savings plan is an annuity. For example, you opens up an annuity, right? You opens up an account from the bank in the bank. You are going to deposit $100 every month, right? For a certain number of years, and that is an annuity. Same amount of money at the same time period. Yeah, every month $100. Or you contribute $500 every quarter, right? Or you putting in $1,000 every year. So if you deposit a fixed amount of money in the account every at the equal time period, then that savings plan is called an annuity. Okay, there are two types of annuity. There are two types. One type is called ordinary annuity. The other is called annuity deal. What's the difference? Ordinary annuity is you contribute your payment at the end of each time period. For example, deposit $100 end of each month, or $1,000 end of each year, or $500 end of each quarter. So that's ordinary annuity. Annuity deal is you deposit the beginning of each time period. For example, deposit $100 at the beginning of every month, right? Or the $1,000 at the beginning of each year. So that's the difference between these two types of annuities. And we do not cover annuity deal. We only do ordinary annuity. So the periodic deposit always made the end of each time period. The end of each month, the end of each quarter, the end of each half a year, the end of each year, and so on. Okay, so we only do ordinary annuity. Ordinary annuity. You might remember in the finance app we learned on Tuesday, TBM solver, the last entry says payment : END begin, right? Yeah, because this means this actually give you an option to tell the calculator, is your annuity ordinary annuity or annuity deal. If you select begin, that means your annuity is annuity deal. But no, we never use begin. We always have END highlighted. That means our annuity is ordinary annuity. Okay, the payment is made at the end of each time period. So that's the last entry. Always use END. We never use begin. In the previous semester, I had students ask me, everything is the same with yours, but the answer is different. And I looked at her calculator. Begin is selected. We never select begin. We don't do that. Okay, we use END. Very good. So that is the definition of annuity. Briefly explain. Let's find a problem to practice. I'm gonna skip those warm-up problem. Number 4, number 5. Okay. Oh, this is about stock. Shares of ownership in a company are called stock. If you sell shares for more money than what you paid for them, you have a capital gain on the sale. Some companies distribute all or part of their profits to shareholders as dividend. Those interesting knowledge, I think you can just figure out on yourself. Let's see, what is this about? With you pay taxes on the money okay. This is about Roth IRA. Roth is the name of a senator. I think he was the sponsor of this type of IRA, individual retirement account. So they named this type of IRA after him. So Roth IRA is opposed to traditional IRA. Traditional IRA is tax deferred savings plan. Whatever the money you put in the account, you don't pay tax at that year. You own, but after you retire, when you withdraw that money, and you pay tax, because we assume typical person make less money after retire and has a lower tax rate, so you save money. But Roth IRA is different. Roth IRA, you pay the tax on the money that you deposit in your account. So you pay tax, is after tax contribution. Of course, when you withdraw, you don't have to pay again, right? You don't do double taxation. A very great news about Roth IRA is when you withdraw the money after you retire, the capital gain from your deposit also is tax-free. So that is very attractive. That is very attractive. So you put your money in a Roth IRA. The money does not just sit there. The money gonna do something, right? They're gonna, maybe the manager put them in the stock market, and maybe put it in some other funds, and it will produce interest. It will produce gain. And after you retire, you withdraw the money, and even you withdraw the gain, the capital gain still tax free. That is very attractive for Roth IRA. But you can withdraw your earning tax free beginning when you are, I think is this. Let me see if it's correct. Oh yeah. I think probably because when people get older, when people's age getting close to 60-year-old, they are considering retire. So the time limit for you that you are allowed to withdraw the money from Roth IRA is 59.5 years old. Yeah, those I think is very interesting. Maybe you are still young at school, you don't really think about those things, but the earlier you think about it, the better your future will be. You should plan. I'll show you some questions. You should plan as early as possible. We need to find an annuity problem. Oh, this is about bonds. Bonds is not part of the company. Bonds, if you buy bonds from a company, you become a creditor of the company. Means you lend the money to the company. So the company is obligated to pay you interest when the bonds mature. The statement says people who buy bonds are purchasing shares of ownership of a company is false. Stock, if you buy stock, that you own a share or how many shares of the company. But bonds is not. The true statement is supposed to be people who buy bonds are lending money to the company. Yeah, this one. This is an annuity problem. Okay, yeah, let's work on this problem. When you see an annuity problem, how do you know it's an annuity problem? Normally, it tells you, look for the keyword. It will tell you, look at here. It says annuity. So you know, okay, this is an annuity problem, right? When you read through the content of the problem, you should take notes. You should take notes. What's going on with this annuity account? The rate that offered by the account is 5.5%, right? So you take notes, okay? R is 5.5%. The interest is compounded annually, okay? That means the little n is 1. And you are going to contribute to the annuity for 35 years. So the lifetime of the annuity is 35 years. In 35 years, the annuity matures. That's the plan. And the way you invest in annuity is every year, the end of every year. So you can see this is ordinary annuity, right? The end of each year. So is you put PMT. We use PMT to represent payment. Your periodic deposit or annual payment is $6,000. So write those down. Write those down. Take notes when you read through the content. We could use a formula to find the value of the annuity in 35 years. Yeah, by the way, the value of an annuity refers to the accumulated balance in the annuity account. It refers to the future value of the account, like accumulated balance. Basically, you open up an account, right? The savings plan is the end of every year, you put in $6,000 for 35 years, and the account pays you 5.5% compound interest rate, compounded annually. And then you want to know how much money you will have in the account in 35 years. So that's what's going on in this problem. It's an investing situation. If you want to use the formula, you're going to use the one in the middle. Oh, actually, use this one. The one in the middle is the general one. You just need to put n equals 1. If n equals 1, you have the first formula. And as you can see, the formula is very complicated, right? I don't really recommend you use this method. But if you want to use this method, no, P here is PMT. It's supposed to be PMT. Because we have a P specifically represent principal, right, in previous section, so it's really not good here to use P as payment. Knowing P here is supposed to be payment. And R is the annual interest rate, N is 1, T is 35 years. You can use that. Or we can use the TID4 calculator, okay? I'm going to show you how to use the TID4 calculator, the TBM solver for annuity problem. TBM solver. You will see big N, I%, PV, PMT, FV, P per Y, C per Y, and PMT, END, or begin. I'm showing you how do we use the solver to process an annuity problem, okay? Capital N here is a little n times T. Is the total number of times the interest is compounded over the lifetime of the annuity, 35 years. Since you deposit once a year for 35 years, and your capital N is supposed to be 35, right? Yeah, 1 times 35, 35. And the capital N is also the number of times the interest is compounded over the lifetime of the annuity. The interest is compounded annually, once a year, for 35 years. So the total number of times the interest is compounded over the lifetime of annuity is also 35. Knowing the frequency of the interest is compounded is the same with the frequency you deposit your payment. Always the same, okay? Because that when you deposit the payment, that's when your balance changes. So they compound the interest at that time. I% is the annual interest rate. In this case, 5.5. PV, I want you to remember. Oh, actually, I want you to help me to figure it out. PV here represents present value. How much money do you think you should have in the annuity at the very beginning? Present value is the amount of money in the account at the very beginning. Can you tell me how much money do you have in the account? You open up an account, a new account. You deposit $1,000 at the end of each year. At the end of each year. So how much money do you have in the account? John is not. The end of each year. So the account actually have zero money there. The account has no money the first year, the entire first year, until you deposit the first payment the end of the year, the end of year 1. You see that, guys? Because we are doing ordinary, yeah, thank you. Because we are doing ordinary annuity. For ordinary annuity, the deposit is made the end of each time period. It doesn't matter what time period, even the end of the first month, the very, very beginning, you have no money in the annuity. That actually lower the barrier that make the annuity available to any investors. If you want to save, you want to invest in a savings plan, there's no obligation you have to put anything, right, or whatever. You just can open an account. You don't have to put anything in it. So that is a good thing. So present value, please remember, the present value for an annuity is always 0. I'm going to say this 2 more times because it's important. Since we are talking about ordinary annuity, the first payment is made at the end of each time period. There's no money in the account the very beginning. So the present value of any ordinary annuity is 0. Okay, one more time. The present value for ordinary annuity is 0. Okay, payment is 6,000. I would put a negative 6,000. If you don't like the details, you can just ignore that. It won't change nothing. But I would put a payment as negative 6,000 because that's the money going out. Every year you have $6,000 going out. That's the periodic deposit. Future value is what you're trying to figure out, right? You want to know how much money should I have in 35 years? We will figure that out. Knowing P per Y, C per Y is our little n. In this case is 1. P per Y stands for number of compounding period per year. P per Y. Since the interest comes annually, the compounding period is 1 year. There's 1 year in a year. Every year there's 1 year, so P per Y is 1. C per Y represents the number, actually I messed up. Sorry, C per Y is the number of compounding, C compounding period, this is 1. P per Y is the number of payments. P here is payments. Number of payments every year. You do 1 payment every year, so your P per Y is N. Just know P per Y, C per Y always equal to each other. P per Y, C per Y always equal to each other, equals a little n. That is 1, all right? That is 1. Okay, ready? I'm going to put those information to the calculator. I'm going to show you how do we start it, okay? Apps, finance, TVM solver. Okay, capital N is little n times time of years, T. Little n times T. Annual interest rate, whatever it is given, right? It is given 5.5%. So 5.5. 5.5. You don't have to worry about convert to decimal. PV. Okay, guys, what is the PV for annuity? We are doing an annuity. What's the PV for an annuity? Thank you. Thank you, John. 0. Very good. Payment is 6,000, right? Oh. Yeah. So I'm going to put a negative 6,000. Negative sign is right here, not the minus sign. Negative 6,000. Future value is what we're trying to figure out. So I always put a 999 to hold a place to remind myself that's the variable we are going to solve for. P per Y, C per Y is 1 annually. Little n is 1. And now we solve for future value. Alpha, enter. Oh, in the future, you are going to have a lot money, right? Let's see how do we round it. Do not round until the final answer, then round to the nearest dollar as needed. Okay, nearest dollar. So here 1 is less than 5, so round it down. We have 601,508. 601,508. If you think about it, it's really doable, right? Every year you only put 6,000. It's doable the whole year, right? And in 35 years, when you retire and you have over $500,000, yeah, you can buy a house probably, or you travel around the world, right? Or just live on it. Part B, what's the interest? Okay, when you need to find the interest for an annuity, I recommend you do the following things. You're gonna write down money going out and the money coming back, because you are investing, right? You have money going out first, and then after 35 years you have money coming back. Let's see what's the amount for each. Money going out, every year you put in 6,000. Every year you have 6,000 going out times 35. That's how much money going out, right? Let's see, what is it? We need a scientific calculator to be enough. 6,000 every year times 35 years. Oh, you put 210,000. 210,000. 210,000. That's the money going out over the 35 years. What's the money coming back? After 35 years, you will end up with have a lot more money, right? This is what we get earlier. You're gonna have $601,508. Yeah, that's a lot, right? And the difference is the interest. The difference is the interest, is your gain. Let's do that. Let's use 601,508 to minus the money you have been putting in, 210,000. Not bad, not bad at all. The interest is a lot of money, right? It's a good plan. And as you can see, the interest rate is only 5.5%. It's normal. Maybe a little bit higher than current rate, but it's totally doable, totally doable. So this is one question about annuity, all right? This is how do we find future value of an annuity account, and how do we calculate the interest from the annuity. Next, I'm going to find a different problem. And this one is similar, right? This one is similar. Would you like to do it yourself quickly? It's the same type of question. We need to find the value of the annuity. Right? Look at your do you have a TI-84 calculator yet? You should get one. All right. Do you want to try that? Yeah. Okay. Let's try it together. I have a handheld calculator. I'm gonna use that. All right. So read the question first. Use the appropriate formula. Do not use formula unless you really want to find the value of the annuity. So the periodic deposit is $100, the end of every 6 months. Rate is 4.5%, compounded semi-annually for 40 years. So you should take a note first on your scratch paper, right? For example, little n is 2 because semi-annually, right? Twice a year. R is 4.5%. PMT is $100. T is 40 years. And let's see, would you have the same thing with me? I'm using my handheld TI-84 calculator. TBM solver. Yeah, what is your capital N? I% is easy, right? 4.5. Yeah, what is the PV for annuity? Payment is $100. It won't take you too much time. Maybe just shy 1 minute, you can get it done. All right, I have mine. What's yours? We need to round to the nearest dollar as needed. Mine is 21911, 21911. Oh, since the nearest dollar rounded up, 912. $21,912. Do you have the same thing, guys? I probably should wait a little bit longer, right? Negative? Oh, do not worry about that. Even you have a negative, just ignore it, all right? Just ignore it. What I would do, ideally, you would do this. 2 times 40. Is that 40? 4.5? 4.5. And PV is 0. Payment is supposed to be negative because when your money leaving you, that's negative, right? And then the future value would be positive. When the money coming back, that's positive. Alpha, right? That's positive. You won't have a negative sign. But as I said, do not worry about it. If you put the payment just 100, that's totally fine. And the future value will be negative. Just ignore the negative sign. You know you won't have a negative $21,911 because you are investing. You will have a definitely positive. All right. I put a 1 on PY and CY. Oh, yeah. We need to fix that. It's gonna be 2 now because the is semi-annually, right? You set a alpha enter when you get it down to end. Yeah, after I have everything ready. Yeah, after we have everything ready, right? So I put the 9999 to hold the place for the variable we are going to solve for. Yeah, after I check everything is correct. END is always selected, and then we go back, future value. Yeah. Oh, I forgot to say this. You need to make sure the indicator, whatever you call that, is blinking at future value. If we are solving for future value, you need to make sure the thing is blinking at future value. And the calculator know, okay, I'm going to solve for that variable. And then you do alpha is the green key. Is that green? Yeah, it's green on my calculator. And enter. And then you will have the future value. Is that clear? That's why I was on. Oh, yeah, you need a, yeah, I forgot to say that, my bad. Put it back. So yeah, the last thing you need to take care of is END. But you have to go back, future value. If we are solving for future value, we need to make sure the thing is blinking. You see that? Blinking at future value. And then you alpha enter. Right? Okay, so let's see. Anybody has the interest found? Anybody has the interest found? So that's the first part. What's your interest? Yes, that's what I was missing. Oh, yeah. My bad, I forgot to tell you. You have to move the indicator to where you're going to solve for, blinking, and then you do alpha enter. Yeah, give it a try. Give it a try. All right. Okay. So anybody has the interest found? John has that. Let me see. Firstly, the rounding doesn't seem okay. Let's see. Firstly, the rounded to the nearest dollar. First, the rounding is wrong, right? Secondly, your interest is too much. Your interest is too much. The future value is 21,912, and your interest is simply just most of them is interest. I don't think. Okay, let's do the interest together. You're gonna do money going out. Okay, how about let's make sense. Just use common sense this chapter. A lot of times we need to use common sense. Let's figure out the money going out. Every half a year, $100 going out. If every half a year, $100 times 2, that's how much money you put in the account for 1 year, right? Times 40, that's how much you put in the 40 years. Yeah, you put in $8,000. You put in $8,000, but you will have $21,912. So if you use $21,912 to minus 8,000, that's your money. That's your money. The difference would be the interest. That's from the bank. So use that to minus 8,000. 8,000 is going to be 21 minus 8, 13, 21. 21 minus 8, 13, 13,912. 13,912. Right? Yeah, awesome. Very good, very good. Awesome. Yeah, be careful of the rounding. Be careful of the rounding. I mentioned that last class, right? Every semester we had students messed up the exam 2. I was told this exam 2 is harder than exam 1. But I think with TID4 calculator, it's so easy. Everything is so easy. You just need to understand the variables, understand the meanings. Okay, I hope you are following. Next question, I think I want to find a different one, different type questions about annuity. Give a little bit of time to react. Yeah, this one's different. As you can see, this time the periodic deposit is a question mark. You want to figure out how much money to invest the end of each year in an account that pays 5% compounded annually for 19 years. Then you can have 130 grand in 19 years. So this is more practical in this culture because people normally save for a reason. It's not like in my culture, we don't really have a reason, which is to save whatever we can. So in this culture, people save for a reason, for children's education, tuition in the college, or save for vacation, right? So there's a reason you save. How much you want to save in how many years, right? You set up the financial goal, and then you determine how much to contribute periodically. So that is more practical. Let's see how do we process this problem. Suppose you want to use a formula. You use this one, okay? The last one, the third one. A is your financial goal. A is your financial goal. A is your financial goal. P is PMT, periodical payment, PMT. So if you want to use the formula, that's the one. Or we can use the calculator, right? Let's sort the information. This time, we are going to find the PMT. Let me repeat it. In this question, we are looking for the periodic deposit. Means we are looking for PMT. We are looking for PMT. So this value is the one we are trying to solve for, okay? So I put a 9999 to hold a place, and later we know what are we trying to solve for. And then we figure out, we take care of other entry. Each year, little n is 1 for 19 years. So 1 times 19. Capital N is little n times t. I%, what's the interest? 5%, so put a 5 here. Again, PV for annuity is 0. PV for annuity is 0. And future value is given in this case. Yeah, your financial goal is the future value, 130,000. 1, 2, 3. And P per Y, C per Y, this time is 1. It really depends on the question. If it's annually, is 1. Semi-annually is 2. Quarterly is 4. Monthly is 12, right? Yeah. P per Y, C per Y is the same thing. END, again, END. Never use begin. It's defaulted as END. And then, you know what do we do? You see the blinker, the indicator? You have to move it all the way up. at PMT. So now the thing is blinking at the PMT, right? That's where the payment is, and that's what we're trying to solve for. And then you do alpha enter. It is negative. It makes more sense it's negative because every year you have that much money going out, right? So it's negative. Do you see the same on your calculator? Rich, you get that? 4,300. Oh, let's see how do we run it. It's pretty close. Rachel, did you use the formula or you use the calculator? Oh, actually, yeah, I was going to say it's very important. Round up to the nearest dollar. Round up to. You're right, actually. Yeah, but round up to the nearest dollar, not the nearest hundredth dollar. Nearest dollar means regardless this value, just round $6 to $7. So the answer is supposed to be 4257. 4257. 4257. That is rounded up to the nearest dollar. And ratios is very very close. In reality, it's totally fine. If you want to round it to the nearest hundred, that's totally fine. But the question says round up to the nearest dollar. We would have to do that. Perfect. The other answer is correct. Very good. 4257. The last digit, the ones go up by 1. All right. Why do we need to do that? Because the similar reason with the previous section. If you do not always round it up, it's possible you will fall short to reach your financial goal. You might not have 130 grand in 19 years. You might have $129,099, a little bit short, but you don't want a little bit short, right? You want to have 130 grand guaranteed, even a little bit bigger, that's okay. That's the reason we have to always round up to. I appreciate that Rachel paid attention, knowing this is round up to, but knowing we need to also round it to the nearest dollar, because that's the instruction. Very good. Second part, how much dollar of your 130 grand in 19 years coming from you, and how much dollar coming from the bank? So let's figure it out. We can use a scientific calculator this time. Let's see how much money you have been putting in. We're gonna use the answer from part A. Every year you put in $4,257, right? Every year you put that much dollar in an account for 19 years. For 19 years, you want to set up an auto pay. Then you don't have to worry about it. Yeah, auto pay, and that's the money coming from you. That's the money coming from you. And the rest of the money coming from the bank. And now we are going to use the financial goal, the future value of the account, 330 grand, to minus the money you have been putting in, 80883. So sorry. That's the interest. Shy 50 grand, pretty generous. Well, if you think about the 19 years, almost 20 years, that's the reward, right? That's the reward. And over the 19 years, you have been contributing to the account, and the bank has the money, and they can do a lot of things to double, triple, or 10 times the value. So it's a good deal for them as well. Let's see if you have the correct answer. 49117. Okay, yeah, very good, very good. 49117. Yeah, exactly. That's correct. Perfect. We have 13 minutes. We covered the 2 types of problems related to annuity. The first type is to find the future value for the annuity. The second type is this one, to look for the payment in order to reach a certain financial goal. That's the second type. We get that done. And one more question. The last two questions are very challenging. And the question number 26, the last one is very challenging. So we are going to talk about this problem. I hope we can get it done in 12 minutes. The reason this question has a very low successful rate is because it uses effective annual yield we learned the beginning of today. All right, so let's read through this problem. Let's see someone's dream. How much should you deposit at the end of each month in an IRA that pays 9%? That is very high. I'm not sure you can find that high. Compounded monthly to earn 60 grand per year from interest alone, while leaving the principal untouched, to be withdrawn at the end of each year after you retire in 50 years. In 50 years. The numbers are randomly generated by the system. Probably this is happen a 10-year-old child, 10-year-old kid, and the parents are trying to do to invest a plan for her, right? Yeah, that would be great. That would be great. Let's see the kid's dream, the parents' dream for the kid. Let's do some note. N is monthly, so 12. For how many years? Yeah, T equals 50. R, annual interest rate is 9%, very high, right? And you want to figure out how much should deposit at the end of each month. So we are looking for PMT. Okay, so let's see the interest in the time value of money solver. We have big N, we have I%, we have PV, we have PMT, we have future value, we have P per Y, C per Y, they are little n, and we have PMT is made at the end, right? Highlighted each time period, each month. So we are looking for payment. This is our goal. This is our the variable we're trying to solve for. And we know capital N is a little n times T, 12 times a year for 50 years. So you need to make 60, 600, 600 transactions payment. And each payment you want to know each time how much money, right, in the next 50 years. And the I% is 9. Present value, again, for annuity, present value is always 0. Future value, okay. Please read the question carefully. It's worth the time that spend sufficient time to read the problem when the problem has a lot of words. Can you figure out what's the financial goal? What's the future value you want to have? By the way, this is 12. P per Y, C per Y is 12. This 12, this 12, right? And what is the future value? What is future value? Yeah, read the question more times, figure out what's the dream. The dream is in 50 years after the kid retire, this is 60 years old, retire, right? And maybe 65 years old, retire. After he retired in 50 years, from the account, from the IRA account, every year he earned 60 grand interest, 60 grand interest from the whatever in the account. Yeah, it means whatever the money in the account would be able to generate 60 grand for interest, and you just spend the interest and leave the principal untouched. And maybe you want to give the principal to your grandchildren, right? You know, that's the dream. You don't even spend the money, the balance in the account. You only spend the interest generated by the account. $3 million, Tandra, 1, 2, 1, 2. Okay, how did you get that, by the way? How did you get that? How did you get that number? Did you use 9%? Did you use 9%? Did you use 60 grand to divide by 9%? Okay, let me see. If you use 60 grand, 1, 2, 3, to divide by 9%, 0.09. Oh, no. To the start over. Yeah. So if you use 60 grand, 1, 2, 3, 4, to divide by 9%, which is 0.09, that's how much money you should have in the account, right? Oh, hold on. What is the 3 million come from? What is that number coming from? 50 times 6 grand? I don't know what does that mean. So what happened is, you want to use the rate. So basically the account after 50 years become a simple interest. No, not simple interest, compound interest. Yeah. So after in 50 years, the account is not annuity anymore because you won't contribute anymore. So in 50 years, but the interest still compounded 12 times a year by month. So in 50 years, your annuity will turn into a compound interest account. All right. So you want to have a lump sum here that the annual rate times the lump sum times the balance in the account in 50 years give you 60 grand, right? So A is supposed to be 60 grand divided by the rate. However, you do not get the accumulated balance. So A is the future value, okay? A is supposed to be 60 grand, 1, 2, 3 over the rate. However, your rate is not 9% because the account pays compound interest compounded monthly. So your rate is the effective rate. So that's the part people messed up this question. That's the part people messed up the question. So this problem, we need to find the effective rate first. R is the nominal rate. R is just a nominal rate, okay? R is just a nominal rate. And what about Y? Y is 1 plus R over N to the power of N minus 1. Remember we learned at the beginning of today? So you can figure it out. It's 1 plus 9% over 12 to the power of 12 and the minus 1. So I'm going to find the effective rate first, all right? We're going to have 1 plus 9%, 0.09 divided by 12. That is the monthly rate in the small parentheses, and I close the parentheses. That is the compounding factor to the power of 12, and then minus 1. Minus 1. This is the minus sign. And that is the nominal, that is the effective rate, actual effective rate. That's your effective annual yield. Okay, do not round this number. I tried. If you round this number, you got it wrong. Do not round this number. Later, we are going to enter whatever this is. I need to take a picture of it and I can enter it. So you can write it down, okay? You can write it down. That is the effective rate in decimal. That is the effective rate in decimal. Now we can go to the apps and then find our monthly payment. So 12 times a year for 50 years. I% is 9. This I% is a nominal rate, okay? It's programmed to have the nominal rate. PV is 0. Payment is what we're trying to figure out. Future value. Future value is 60 grand. 1, 2, 3. Divided by the effective annual yield. The effective annual yield, which is 0.0938068,977. Do not round it. And yeah, the calculator do the calculation for you. P per Y, C per Y 12. END. And now we go back to solve for future value. Sorry. I'm sorry. Solve for payment. 9999. The number stands out, right? That reminds you to solve a payment. Alpha, enter. So it means you are going to, oh, you only need to pay $55. Is that true? Round up to the nearest dollar. $55? Really? $55? Yeah, let me double check if everything is right. I'm a little bit nervous. 60 grand. 60 grand is the interest over the annual. So the 60 grand basically is the annual interest amount. If you divide the annual interest amount by the effective annual yield, you have the balance in the account that could generate that much interest every year for you. So I don't think that's wrong. 12, 9%, 12 times a year for 50 years, 600. Yeah, 55. Let's try. I think it's 55. Oh, yeah. Right? So if you have a children, 10-year-old, 15-year-old, start it now for her, for him. Every month only take $55, right? And when your child retire, he can live on the interest. Then what about the principal? The principal gonna stay there as something, very, very good deal, right? All right, so that's everything for today. Is that clear, everybody? This question has very low successful rate because it's really hard to figure out that we need to use effective annual yield instead of the nominal rate to find the accumulated balance in an account that could generate 60 grand interest every year. Okay, if not, just please watch the video. All right, guys, that's for today. I'll say good night. It's complicated but making sense. I'll probably watch the video again. Yeah, that's a good idea. Thank you, John. All right, guys, I'll see you on Tuesday. Have a good weekend. Feel free to email me if you have any questions. Yeah, don't forget you have exam 1. Make a plan for it. You're welcome, Rachel. Thank you for coming. Have a good weekend. Bye-bye.